This tutorial is a follow-up to the tutorial about basic symbology. When we ended the last tutorial, we had looked at how you symbolize attributes stored numerically. We had done it for owner-occupied housing, for race, and for median age. Under the list, though, we had seen several other options: graduated symbols, proportional symbols, and dot density. So I'm going to review those as well as some other things in this lesson. So dot density might be one better suited by building it and then talking through it. So in this instance, I'm going to take a symbol, right? For white, we'll have it be an orange dot. For black, we'll have it be a blue dot. And for Asian residents, we'll have it be a green dot. So it's a dot. Size is 2. I can change that size. And the dot value means that each dot you see on the map is going to represent 500 of something. In this instance, 500 white, 500 black, or 500 Asian. I'll make it a little bit smaller so that each dot is now representing 50 of its respective population. We'll make 1.8 the size, try to get something exactly right. Hit OK. And now we've colored things up in such a way that within each census tract, for every 50, whatever, white, black, or Asian, there is a dot of the appropriate color. So whereas previously we had shown a map, right, I'll recolor this one. Previously we had shown a map, oops, that looked similar to this. Areas where there were more black than white people in blue, and the other way around in orange. Hid some nuances. It makes it look as if these neighborhoods are entirely black, when really all this is showing is number of black residents are greater than the number of white. Here, you can actually really begin to see where areas are mixed versus areas that are heavily black. So let's zoom in, and we can see in these western ones are predominated by, and let's make these dots a little bit bigger so we can really see. Oh, that's an interesting thing. Just make sure you know, when you zoom in, your dots tend to change, right? So you have to be careful about that. Make it 50. Well, I'll make one dot be 10. Cell size of 2. There we go. So now I'm looking in each of these census tracts, and now I can begin to see ones where it's heavily black, or heavily white, or really, really mixed. Now it's important to know these dots aren't representing where actual people live. They're just put randomly throughout whatever bounding geography you have. So I had a census tract, so they're just distributed randomly. For example, this census tract right here, if I open it, there are 5,776 black residents, so there would theoretically be 576 black dots there. There are 122 white residents, so strewn throughout this you would find 12 of those, right? Because one dot equals 10 of a population. So this is a way of showing when you have multiple variables that you want to show within one kind of geography. Using dot density is a way to do that. Another way is with something called graduated symbols. So graduated colors, we'll pick, let's do black residents, 4. Right, if black residents colored things up by the number of black residents, graduated symbols applies a symbol with those values, right? The larger the symbol ascribes to more people. Now this can be used with polygonal layers, but it often makes more sense to use something like this when you're focusing on, let's see if I can find it. I'm looking for a schools layer that I have. It often makes more sense to do this when you have point layers. So if you please give me one moment, I'm going to find, there we go, schools. Right, so now I've got a layer of schools. So if I open this up, I can see that each school has enrollment, so the number of people that are enrolled there. So a point layer, I would do enrollment and do graduated symbols, right? And that makes a lot more sense. We're used to having them be points. We can see them scaled by the number of students that are at each school. So again, you can do graduated symbols for polygon layers, but what it does is just places a circle within whatever the geography is. In this instance, it's census tracts. So the third here is proportional symbols. In fact, I'm going to do that with schools to make it a little easier. So I'm going to run proportional symbols, see if it makes sense what I did. So I picked enrollment again. I'll make the smallest there. So exactly, it's multiplying their value by a factor of their size. So this, and this, the larger one is about 4 times larger. And you can see that here. This is about 4 times larger than that. Whereas that becomes larger and larger still. So we're graduated symbols that we had used previously, right? 985, that's 900 times more than 1. Right? It's not a ranged value. This makes it actually proportional. So each thing's value, it starts with whatever the smallest is, increases by size, it's something that's proportional to the smallest size. So those are the 3 ways when you're messing with quantiles. So another way of looking at multiple pieces of data, and I don't use this much, but it's important to teach it, is charts. And I'm imagining you could figure out what this is. I'm going to put white and black residents again. I'm going to say that white residents will be orange. Keep in keeping with that color, and black residents will be blue. Right? And a pie chart is put in each. Now look at that. There's just way too many right now, and it's trying to include all of them in my view. But if you zoom in, things start to get a little bit nicer. So what each thing is doing here is it's just showing via a pie chart the percentage that's white and black in each neighborhood. You could do the same thing here with a bar, right? Even still, you could do it with a stacked column. So graphing is simply a way that it takes certain multiple attributes that are within one geometrical feature, and it shows them graphically. We mentioned we would get to these in a moment. Categories, unique values, many fields. Probably pretty easy to figure out what this is. So I'm going to take the race category and the occupancy category that I had earlier, and it just makes all the possible combinations of each, right? So if you combine these 2 categories, you could possibly have one that's black and owner-occupied, one that's black and predominantly renter-occupied, one that's white and predominantly owner-occupied, and one that's white and predominantly renter-occupied. So nothing as complex as what we've just learned. It gives you just a way to take multiple attributes that are categorical and combine them together to make all the possible combinations between the 2. So let's say I actually liked this. I like looking at areas that are, mostly black and owned. So I'll say black, the owner-occupied. Let's say that this is called the neighborhood typology. Right? So it's black and owner-occupied. This is black and predominantly renter-occupied. Would be if we spelled it right. White and owner-occupied. And finally, white and renter-occupied. So I enjoy that very much. Enjoy it so much, I'm going to do save a layer file. So saving a layer file, and I'm going to put this on my desktop so I can just easily access it. Oh, typology. Oh well, we're just going to keep it. So what I've done there is I've created here in our catalog, not a shapefile like we're used to, but a layer. And what it means is I can drag it in, right? And it knows the layer, or it knows how I want it to look in here. I can also take something like black and white, go to properties, and through something called import. Oh, import. I think it's match symbols actually. Import is a little different. So I would take this, find it. Oh no. Oh, that's a set file. My apologies. Ignore everything I was saying. Import, yeah, is similar, but instead of finding the layer that I saved, import can take on the value of another field that's already in your layer window, right? So I could make this now look like equal interval. It's asking me what field should it use to match the value field. Since it's the same thing, I'm just going to say median age. And then it would take on the symbol of another layer that I have. Right? And I now want it to look like quantiles. So I would go down to, import quantile. Race cat. Here, we'll make it race cat. Make sure it's the same thing. Whoops. Got confused there. Apologize for messing up. All right, one's race cat and one's category. That's what we want. And now it will look identical to quantiles. So again, two ways. Import allows you to take on the symbology of another layer that is already in your layer window. Right-click Save as Layer File allows you to create a layer file that you can drag in.